Hello everyone. I'm Clemente, and this is my doctoral thesis. And it's about how to model lexical relations of text with language models. We detect two main problems. In this case, the first one is the complexity of language models is very large, and they cannot be run in environments with low hardware resources. And the second problem that I can see in this context of language models, large language models, is that the data is also large. And in language with few text collection, it is possible to get a big multi-track large language models. And when I can see another problem that I consider this as an extra problem is that the embedding the embeddings have a lot of interpretability. And well, what is my objective and my main goal of this research?
It's okay, it's okay.
We can also try the project.
Yeah, probably after this presentation, so we'll need to.
Well, we want to experiment with language models in the generation of word embeddings using lexical relations. In this case, we are using, as a first experiment, we are using WordNet in English. And we are using these word embeddings for text classification using convolutional neural networks. And well, we are trying to increase the performance in the language models and in the classifier models, while reducing the complexity. Well, my methodology, and this is the final slide. The first one step that we have is that we want to review the specialized literature about the generation of embeddings. Of course, we have a lot of articles and papers to review from Colobert embeddings, word embeddings, and so on, even with BERT embeddings. And the next step is that we want to search for a good lexical resource that contains lexical relations, for example, the WordNet, or the ConceptNet that is another new resource. And well, now we are in the implementation and algorithms and tuning of them, and we have different results on text classification and lexical similarity task, where we can see very good results versus Word2Vec language model originally tried with Google News with 300 features. And well, my last step is the evaluation performance and comparison. And well, now we are using another language model. This is the web model, and well, we are experimenting with that. And that's my very brief explanation of my thesis and my research.
I have a question.
Yes.
Are you using, for which languages are you doing this, or is multilingual?
For this, we are using only these lexical resources for English.
For English, okay.
And we are thinking about to use, to change the language to Nahuatl, Spanish, or even Spanish.
But have you and compare your models with large language models in similar tests? Since nowadays LLMs are like dominating in most tests, have you compared your specific models to large language models in performance?
In this time we are only comparing with word-to-vec models.
Okay.
And the next step is to compare with large language models. For example, BERT or even GPT.
Okay, good. And finally, regarding computation, for example, on average, which kind of equipment are you using to train your networks? And how long does it take to train?
How long? Well, I don't have my computer here, but it's very fast to train with word-to-vec.
Okay.
The lexical models, because we are taking a relation to train a model. Next, the following relation, train another model, and so on with all the lexical relations with the word source.
Okay.
And it's very fast.
Okay,
Very
nice.
fast. Yes.
Thank you. I think I understand what is your proposal, right? Proposal?
Propose?
Yes, this is my test proposal.
So I see that you proposed to apply CNN.
Yes.
Why CNN?
Why CNN?
He said we are in the era of large language models. So why you propose to apply CNN?
Okay. First, as we are training different models for different lexical relations, we have different models, different language lexical relations. And well, the first question is how to train fine-tune, or how to do a fine-tuning with this embeddings, with these lexical models. So that's why we are using convolutional neural networks, because we want to separate the information about the lexical relations. We want to have the information of every lexical relation separated, and the convolutional neural networks, we think that can improve the classification results, and even to get a vision about the interpretability of the events. And that's we want to.
Okay, so this is master thesis.
That is a doctoral thesis.
Doctoral thesis. Okay, and you are in what semester? You are starting?
I'm in the fifth semester.
Fifth semester. Okay.
¿Dijiste de dónde vienes?
I'm from Universidad de la Costa, specifically in the Instituto de Investigaciones en Inteligencia Artificial, and now I'm doing a research stay with doctoral analysis.
Okay, research stay. Okay.
Research stay.
Well, I didn't quite understand what is the problem you are solving. You say, I'm working with embedding, which is fine. Everyone now is working with embedding.
Yes.
Word-to-vec and then BERT. Well, so what problem? Then you say lexical relations. Yes, so what kinds of, but probably you may define first the problem. Because next slide you say problem. But, yeah, the complexity, but what are you solving? What do you want to solve?
The evaluation
Relation of what?
of my embeddings.
Lo que quieres saber es cuál es el problema que hay con los embeddings actualmente y qué es lo que quieres resolver. O sea, ¿por qué quieres entrenar otros embeddings más y qué va a resolver tu modelo de embeddings?
¿Y en qué datos lo quiere probar?
Bueno, en inglés.
Puedes intentar hacerlo en inglés. Si no te sale, en español.
Well, the first one problem is that to generate new embeddings is very costly from scratch. and those embeddings lack of interpretability, and well, to produce embeddings in another language with few text collections, few with low resources is very complicated to generate embeddings from scratch. This is a view, a very fierce view.
So you want to generate embeddings from scratch and with few data. It isn't possible.
Yeah.
With few data,
That's what he wants to do.
with few data, and with few
Resources.
Because few resources.
Computational
You will have some embedding, but it will be very bad embedding. So you are generating embeddings for low resource languages.
Yeah, but he's working with English. Ironically.
Well, you can imagine English has few resources. Take some text.
Yeah.
Okay, yeah, it's fine. But you can compare. This is a good idea. Let's imagine that English is a low resource language. We'll take just few resources for English.
Yeah.
We'll make all experiments with English, and we'll have a lot with what we can compare. Right? So yes, this is a good idea. Yes. Well, great. Still, I don't understand. Yes. You are practically terminating, so. Well, so you should hurry up. Hurry up.
Dice que te tienes que apurar porque prácticamente ya estás terminando tu
Sí.
tesis de doctorado y que no vieron muchos resultados.
No lo dice,
El advisor tomar cartas del asunto. Bueno, ok, pues gracias.
Yo tengo aquí su...
Sí, yo sé.
Ah, ok.
For this one, we do need to turn that up.
Vamos a conectar. De aquí conectar.
Islam para que baje de diapositiva.
My thesis topic, I'm sorry I did the presentation in Spanish, but I will speak in English. I hope it's going to be understandable. I'm a master's student, and the topic of my thesis was going to be information retrieval in the legal area. And I want to employ a dense retrieval model. And my supervisor is Dr. Helena Gómez. And so the agenda is going to be, I want to give you a quick introduction to what is information retrieval, then what is dense retrieval, and specifically, and thirdly, I want to show you an article that I want to use in my thesis and explain what they did in this article. And the fourth part is how to train a language model for the information retrieval task. And then I want to show you the results that are not my results, they are the results that the people obtained in the article, which is kind of a motivation why I want to use their approach. And finally, I'm going to talk about mine. So I'm going to turn this off so that I can. And so information retrieval is basically the task of we get a query to our database of documents, for example, and we want to recover the K documents most relevant to the query. And there are a few special challenges in the legal area, because we have, especially nowadays, that we have varying lengths of our documents, and especially compared to documents in the internet, for example, the legal documents can be very, very long. And another challenge is the language that is used in the legal area, which is very specific, and we all know that we read some legal document and we don't understand much, even if it's in our own language. So what is dense retrieval as a sub-area in information retrieval? Dense retrieval uses a model like an encoder model like BERT, for example, and the idea is to create the embedding or the vector representation of all the documents in the database. So for each document we have one embedding, and then the user types this query. The only thing we have to do is to encode the query, generate the embedding for the query, which is very fast. And as a next step, we compute a similarity score between the query and the embedding of each document in the database. And even if the database is very large and has millions of documents, this computation, if you have a GPU, is very fast. And so then we have a similarity score for the query and each document in the database, and we can just simply rank the similarities and return the K most important documents in the database. Yeah. And I'm going to skip the slides. And so now I want to talk about this article that I read and that I want to use in my thesis. So usually in dense retrieval, as I told you, people use encoder-only models like BERT, for example, because what they do well is with embeddings. Their embeddings represent the global context well of the intertext. So what they did in this article is they wanted to convert a large language model to basically an encoder model to be able to use the language model, the large language model, to generate embeddings that represent well the global context of the input text. Because, as you probably know, large language models were pre-trained with a casual language modeling, which means that they are pre-trained to predict the next token based on all the previous tokens. So the embeddings don't represent well the global context of the input text, but more like the local semantics and the next token that is going to be predicted. And to adapt the large language model to act as an encoder-only model, they proposed two pre-training tasks, which they call IIMAS and IBAR, which stands for embedding-based auto-encoding and embedding-based auto-regression. And the basic idea between the two tasks is for the IIMAS task to predict the embedding for the input text itself, and for the IBAR task is to predict embedding for the next sentence following the input text. And in this way, they say if the model is able to predict well every token of the input text, then the generated embeddings are a good representation of the global context of the input text. And so, next slide, please. So a few more details on how they did these pre-training tests. And the first line is for the IIMAS task, where they feed into the model the input text itself. Then they tell the model when they append the input sentence is, and then they add the special token. And so with this prompt, the model is forced to generate the embedding for the input text. And then we can, I think that's what they're referring to with -1. Then we can extract this vector or this embedding from the hidden state in the last layer. And once we have the embedding for the input text during training, we can compute a loss function, which basically compares the similarity. Here we compute the dot product, which is good because later we also use a dot product to compare the embedding and similarity, or to compute the similarity. We compute the dot product between the embedding of the input text with embedding of each word in the input text and divide it by the sum of the similarity between the embedding of the input text and each word in the vocabulary. So we basically get a similarity. We basically see how similar is the embedding to the input text. And for the IBAR task, it's the same, just that the model has to generate the embedding for the next sentence, following sentence. And I think why because I told you that we only want to have embeddings that represent well the global semantics of the input text. So for me, initially, it wasn't quite clear why they want to also have embeddings that represent well the next sentence if we don't want to have a generative model afterwards. But I think the reason why they added also this pre-training method is to also integrate the context around how they on the parameters that they use for the pretend, but they're not that for rather they 10,000 steps with a hair size of 256 and sequences of I think 1,024 and learning rate of 65 and stuff. And another detail, which is not that important, is that they do the two pre-training tasks at the same time. So they use one prompt for the two pre-training tasks to save half of the resources and the next time. And now I want to explain to you how to train a model for dense retrieval or for information retrieval in the dense retrieval area, which they also did in the article after these two pre-training tasks. But this is a general approach. It's not specific to the article itself. So So another preliminary is that the data set in information tree will contain a number of queries and annotated documents that are relevant to the queries and not relevant to the queries. So, and with these annotations, we can train the model for the information retrieval task. And so the way training works is, so this is, here we see one batch. One batch contains one query, one relevant document, and a specific number of irrelevant documents. And the way the training works is we encode each of the documents with our transformer model. We obtain the relics, and then we calculate the similarity between the query and the relevant document with the dot product. And this happens outside of the document, outside of the model. And we also compute the similarity score between the query and irrelevant documents. And now we have this one similarity score and these n similarity scores. And with these similarity scores, we can compute a loss function for training. And we basically, the goal is that after training, the embeddings of the queries and the relevant documents are very close to each other in the semantic space, and the embeddings for the queries and the irrelevant documents are very far away in the semantic space. So, here too, we can see that in the loss function above we have the similarity between the query and the relevant document. So we want this to be very high. And here beneath we have the similarity between the query and the irrelevant document. So we want this to be the similarity to be very low. And yeah, so this is the next step. They also did an article to depth the model for a specific data set and for the information retrieval task. And these are the results that they obtained in the article, and the article was published this year, and they obtained the new state of the art. And you can see that they only improved the scores by a few percent, but I think information retrieval is is an area that was studied a lot, so an improvement, a little small improvement is still good. Okay, next slide. So my proposal for my thesis is I am working with a data set of legal cases from the Supreme Court of Paraguay. And so right now we have 5,000 legal documents. And so the first step, we need to be able to train a retrieval model on this data set. We need to annotate the database with, we decided to use 150 queries that we have to create 30 documents. And after this first step of the annotation, we want to do the same thing they did in the article, but the problem is in the article it uses Llama 2, and it only knows English, it's not multilingual. But the Llama 3.2 is already multilingual, and I want to use the smallest model, the 1 billion version, and do these two pre-training tasks with the Spanish Wikipedia, and also using methods to reduce complexity, like lowering annotation, which they also use in the article actually. And so yeah, the last step would be to do the fine-tuning, which I explained to you in the last slide. To do the fine-tuning with our already annotated database of legal cases. That's it.
Okay. So, any questions?
Can you show the first slide?
Yes.
This?
Okay, so this is the proposal. Starting
Yes.
with,
Yes, yes.
this is master.
Yes, yes.
Why?
Because we have a collaboration with the Supreme Court, and they need to build a semantic search on their jurisprudence system. Actually, right now, they have a lexical search implemented. So this is not useful for the lawyers that want to look for precedents of some cases. They don't usually get the results that they need. They only get the results when they look for specific words and how it is written in the documents. So this is a little bit hard for them. Yeah, we have a proposal for funding for a grant with the CONACYT system in Paraguay. So this is what he's going to do a research stage here in Paraguay. See, he will be working there. Yeah, this is important.
Yeah. You mentioned that you are indexing 30 documents for the last. Yeah. What do you mean index? The queries by documents?
So we have for one query, which could be, for example, armed robbery could be a query, just these two words, for example. But they could also be longer in the whole sentence or something. And for this query, we have to annotate 30 documents in the database and give them a label. This document is relevant, or this document is irrelevant. Yes. So there's another problem there that arises because we have 5,000 documents right now in the database, and you might be wondering, okay, if we choose 30 random documents, probably all of the documents will be irrelevant. So we have to use other search engines that are already present, and use these search engines with this query to get the 30 most relevant documents. And yeah, for each
Maybe you
query.
can do it on the contrary, you just start for the document, you invent the queries which are relevant.
Okay.
That's an interesting approach.
Yeah.
I have a question. You did it with Llama 2?
And no, not me. They.
Okay, that's a paper that's already existed. Okay, good.
Yes.
Have you got experience with the fine-tuning?
With large language models, no, but just encoder only.
Okay. Okay, if you manage to make it, let us know. It's giving us a little trouble here. you're going to use Llama 3.2, which has a 1 billion and 3 billion size. So probably you're trying to go for the smallest model.
Yes, the model.
Have you looked for other models that could work? For example, the Chinese models like Wen, which are even smaller. Because I think what you're trying to do is to use the connections that already exist in the, and it's also multilingual, the Chinese model, 1.2.5. What you're trying to do is to use the existing knowledge of the system and try to give it another layer of specific legal knowledge. But you don't need a super large model like 7 billion from Llama 2 to do that. That would be a premise. Also, you can start from very small and then start going all the way up because Llama 3.1 has the 8 billion parameter model. So you can, if you don't get good results, you can probably try larger models on your way up. But it's good to start with a small model. And finally, I think you're gonna have. I don't know if you're going to annotate those cases by hand, or you just rely on the searches that other system already provides, because otherwise, for example, if it's a semantic thing, you probably need somebody that knows about it to see if your semantics are correct, similarity. Or what do you try to get, or how do you try to measure that it's really what it's meant to in the same meaning of the word.
So you have in the collaboration, we have lawyers or experts, legal experts that can do the annotation for us.
Okay.
And that's the plan that we have.
That sounds really good.
And yeah, and I want to write down later the name of the Chinese one so I can look it up.
Okay, you can find it in the
In
the alumno.ai page. There are several models, but there's a chain of ones. QWEM, so let me know.
Okay.
Okay. Guys, we're already almost 12, so probably some people is going to have to do some things afterwards. So if we could try to keep it more agile, so everybody can present with everybody here.
Muy larga tu presentación.
No, no le piques. Si quieres te ayudo a pasar.
This is my project for my postdoctoral research at IIMAS. The title is, I am Orlando. The title of my research is Identification of Obstetric Violence Indicators in Electronic Health Records. The content is very short. It's a brief introduction about what I do. Indicator sets chosen for this problem. The available data sets, the methodology we use, and experiments and results. This is a definition of obstetric violence. It is according to the government of Mexico. This is the result. It says that obstetric violence is caused by the mistreatment of pregnant women who are judged, intimidated, humiliated, or physically and psychologically harmed. And this occurs in places that provide medical service and is present in all the spheres. This is some examples of acts regarding to obstetric violence. There are more. The first is performing a cesarean section on a woman without her voluntary express and informal consent. This is very important, or well, maybe frequent. And the second, forcing a woman to give birth while lying down or immobilized. I think this point is not an reference. And the third, denying or hindering a mother's ability to hold and breastfeed her newborn immediately after birth. This point, when I realized, was a surprise to me. Do you know that is a obstetric violence, this point? The last is failing to provide timely and effective care for obstetric emergency. This is some statistics from a survey from the Mexico government, just for the energy and direct is the name of the survey. In this are present some prevalence of women aged 15 to 49 who experience mistreatment during childbirth or cesarean section in the last 5 years. In 2016 and 2021, this survey is each 5 years. Well, there are points in Spanish because the survey is in Spanish, but well, I don't know.
¿Puedes explicar alguna?
Yeah,
La primera.
is when the physician or the professional is yelling or regañando.
Scolding.
They were calling to the woman. That is one of the better reference in both surveys in 2016 and 2021 is the last. And another, for example, this is the consensus about the woman to allow a cesarean section. This is a very important thing that we are following in my research. This is the same of the, well no, this is from the same survey and an organization named Grupo de Información de Producción Elegida in Mexico. And this is a map of Mexico and the states in which this mistreatment about the woman is occurred. And also is in the 2016 in Estado de Mexico, 39.5%, Mexico City, and Tlaxcala. And in the last survey was in 2021, also repeat Mexico City and Tlaxcala, and San Luis Potosí, another state. And you can see the colors in the map. The indicator says that we choose in consensus when the Mexico City Ministry or Head of Secretaría de Salud de la Ciudad de México, CEDESA, where this is the Robson criteria classification. Next, I explain what is that. Uterotonics used during childbirth, antibiotics used in pregnancy, the obstetric hemorrhage, and something according with the personal information about the patients. Well, this is a definition of the Robson classification. In fact, it's an implementation manual for the physician to do manually. In October 2014, the World Health Organization says that established as a manual to do to get the data of the institutions because the WHO recommend that every country should be have 10 to 15% of the cesarean section, but this is not good in Israel. And the Rothon classification was created to prospectively identify well-defined clinical relevant groups of women admitted for delivery. And is for all women. It's no matter if the delivery is by cesarean section or vaginal birth. It's for all the women. Next please. This is a picture of the 10 groups of the Robson classification with some particularly attributes that must be included in every group. I think it's not clear. But in the next slides, in this slides, the Robson classification is split in 6 obstetric variables, and these variables also have a granularity of that obstetric variables. In fact, these points are 14, and we use as an entity for the information extraction that I will using to recognize all the indicators. And the first is parity, and also we need to identify if the woman is nullipara or multipara. Nullipara is when she doesn't have any child or pregnancy before, and multipara is if she has children before. Previous cesarean section is just that, yes or no. Onset of labor is if the labor is spontaneous, induced, maybe with using uterotonics or some drugs. The no labor and pre-labor cesarean section is when a woman make a schedule for give a cesarean section. Number of fetuses, singleton and multiple, one baby or 2, 3, etc. Gestational age, preterm is less than 37 weeks, and interim is 6-7 weeks or more. Fetal life and presentation, the most common is the OK presentation, is the cephalic presentation, when the baby is prepared to get out. And the bridge presentation is when the baby is sitting like that, and is a problem in the time of the labor. And the transverse line is when the baby is in a position horizontal. This is a flow chart for the classification of women in the Adorno. It is very easy to, but actually we need to know all the indicators to choose a group in which a woman or group of women have pertenence in these groups. The uterotonics are drugs, also known as oxytocin or embolic, and used to induce the contraction or increase the tonicity of the uterus, is to accelerate the process in the labor. The antibiotic is one drugs. You see, this I have a lot of slides. Right, next, please. Patient. Next. This is the data set I use. I choose 2000 electronic health records from corpus bigger. And this corpus is primarily pertained to 1077 79 autistic patients, aging 14 to 45. Well, it's no relevant. Next, please. The general methodology. We have these documents in a XLM format. Well, in a RAR format, we pre-processing and filter that documents, filter 2,000 documents for annotation processes, using a platform named Archila. And we develop guidelines to do that. And after we, the annotation dataset, we train preliminary NER models to do a prediction task. This is the general methodology. Next. The specific methodology for the annotation process, as I said before, we select some raw documents. We make annotation guidelines for the annotators use and follow the instructions and the rules. After we, in the annotation process, we split that the 2,000 documents in 4 groups of 500 documents, and we have the support of the 3 senior year students medical from the Universidad Americana, 2 medical interns. They finished their studies from the Tec de Monterrey and 2 from the UNAM. In the evaluation, we use a kappa and F1 score to do that. The annotation data set, well, this is just the I said before. This is the entities that we use for the annotation. There are 23. These are the Rotterdam criteria classification and 9 more. The annotation guidelines is no relevant. Next. Next, this is the IOB scale to make evaluation. Maybe you don't know. Next, please. We use 2 evaluation criteria: the strict and relaxed. And the strict is when it's exactly the same tokens from the annotator, and the relaxed is when they are overlapping. In this case, this is the overlapping, so we take these tokens for the evaluation. The results we have finally is divided by F1 and kappa scores. The base is the relaxed with 0.9, almost perfect. The rest of all the entities are split in primary validation and test. We have 18,105 entities. This is we have 1,865 documents annotated. This is for the trained and test. This is the preliminary NER models, but after the training. I use a conditional random fields, that is one of the best traditional models. High to me with BER, XLM Roberta multilingual, because this data is in Spanish, and Roberta, this model is for the Barcelona supercomputing, is training in biomedical documents. Llama 3.1, I was fine tuning, and zero shot prompting with Llama. And the results, that, and the best model were with Roberta. Actually, with Roberta from the Barcelona supercomputing models, and XLM Roberta was the best. The 23 entities are using just the 23 entities, like I said before, and 46 entities is according to the IOB scale, because it's the 2 times the Next, please. Well, it's fun.
Okay. So,
What's a lot?
sorry, I'm going to return to this one. You use Roberta multilingual.
Yes.
Okay, and you got an F1 of 72. Okay. So you're trying to determine, it's just a binary classification whether the patient was mistreated or not in some way, or it's a classification per categories?
This is actually used to evaluate the entities recognized for the model.
Okay, so you're not a
Maybe
classification.
you pass the. I have an example. Next. Before. Yeah, this is the results of the evaluation of the cognitive model. This is the 23 entities and the micro average, macro average, weighted average.
Oh.
This is for entity, F1 score, record, precision, and this is the results I put in the table. The part is for entity.
Because you probably didn't get your task. What is your main task? What are you trying to accomplish with this?
In this stage, but I also need to use this prediction to apply the classification, the Robson classification, to identify in which group Gómez is done, for example.
Okay.
That is not done.
But I don't see the okay, from this you can infer with the Robson classification.
Yes.
From this you can infer that if there was strict violence.
No. It just to identify. Initially, my project was about the obstetric violence, but with many meetings with the people in charge of the CEDESA, the consensus was only use Robson criteria. They did not agree with other things. So the thing that we can do in this is for the Robson criteria, know if the cesarean section was okay or not.
Okay.
That maybe is very close to my idea of my project. But we know identify obstetric violence.
Okay. Okay. Nice. Any question?
Can you go to slide number 41?
Third one?
Yes. One more. Okay. Again. Maybe 29 around 9. Yes. Yeah.
30.
Yes.
Okay, good.
Yeah, I see the data and agreement campus for the pastor 06. Yes?
Yeah.
What does it mean?
What is 0.6?
I think it means 0.06 from 1 out of 1, right? It's very low. I see
Yes.
the campus score is range from 0 up to 1, right? So in domain, in health domain, the administrator agreements, the data is very, very low, 0.006. I mean, you know what I mean? 0.0, if it is mean 60% out of 100, it's very low for the data, especially in the health domain.
Yeah, this is an example on how to do that. I use the library from Scalar to compute that. Also, if you observe kappa is and in this case, where is more, the result has similar parts. We include in this criteria of evaluation the tokens that are not entities. Maybe this is the reason because the results are in that way. But in the literature is evaluated that in that way.
So, but are you saying that the first kappa score is 0.066 or 0.6?
Maybe I have a mistake here.
Okay.
We did 0 before the one. Yeah, sorry.
Yeah.
Maybe Let me check whether I think I may.
It is 16, 60, 60.
Yeah.
Out of 100, it's very low in a hands domain, right?
Yeah, but this is only an example. This is
Yeah.
not the values obtained by.
Actually,
No, this is not the actual data. The actual data is the next slide.
Yeah.
This is only an
Next
example
slide.
of how to, yeah.
This
that's-
is the final, the God data set. This.
okay, what is the final data element?
This is for diversity metric, FAO in the strict criteria, and the relaxed criteria that I was used in the 520 was this document. But
Somebody else? Question? Okay, that's it for the moment. Thank you very much. Oh, you need to unlock. Creo que sí se alcanza a ver las diapositivas y para prender la luz para que también se vea la persona. So I turn the lights on so the person appears in the recording. If you don't see very well, please let me know. So I can turn it off. Okay.
Hello everyone, my name is Gómez. I'm from the IIMAS department. I'm a PhD student in the third year, fifth semester. And today I'm going to present part of our research work for text graph representation and graph neural networks. Please. So, as a brief and general introduction related to graph, as we know, graphs is a general language for describing and analyzing entities and their relationships. For example, we can have a set of nodes, let's say A, B, C, and a set of and some kind of relationship between these nodes as an edges, as a general description. So, for example, a popular one is the social network that we all know. Here we can represent a person and an account, Instagram account, for example, as a noun, as a node, sorry, and some kind of relations. Maybe if you follow some person, we link that with an edge between the nodes. And at the end, we have this graph that we can do more analysis with that. Also, another interesting example is in biochemistry. For example, a molecule, we can represent each atom as a node and the bonds between the atoms as an edges, and with that represent the molecule as a graph, and then use for that for some kind of analysis. Also more natural representation, the networks of neurons. And lastly, why not, represent the text as a graph representation. We could properly represent the text as a graph using, for example, the words, sentences, documents as a nodes, and some significant relationships if you use the edges. No? So, for example, a very simple and popular representation is the concurrence graph. Here we can represent each word from a document as a node, and the concurrence of two words from the document as an edges. Also, we can assign some kind of weights or attributes to the graph. For example, we can assign the part of speech to the node, and also for the edges, we assign the attribute of the frequency of the concurrence. So this is a brief example for a short text. The violence on the TV article discussed the idea of the amount of violence on the news. And the graph representation of this short text is that. The next one, please. Another popular representation is the heterogeneous graph. Here, taking all the corpus, the documents in the corpus, we generate one graph as an output. And here we have two types of nodes. Each word and each document in the corpus we represent as a node. And also we have two types of edges. One is the word-to-word relation for the concurrence of that words. And the other type of edge is the document-word relation. If the word appears in the document, we link that nodes with an edge. And the same, we can assign any kind of attributes, for example, the part of the speech of that node for that word. And also for the edges, we can assign, for example, the PMI metric to the word-to-word relations, and for the document-word relation, the TF-ID. And this is a brief example, short example of this kind of graph. Please, the next slide. So, with that, we notice that build this kind of graph representations will be easy task and tedious. So we decided to build a library in Python called the Text-to-Graph API. The idea here is to build in a more easy and flexible way this text document into text graph representations. So, for example, this supports the concurrence and the heterogeneous graph that I described before. And the library is very simple. Here we have three components. You take the text as an input, and the first is a basic text cleaning and normalization process. Then the most important module is the graph model. Here we build the nodes and edges according to the input specifications. And lastly, the graph transformation that we take the graph model and take as an input appropriately, as an output appropriately output. For example, the network X object, this is metric, and so on. It depends on the task that you are going to solve. So why and how do we use this graph? Mainly we use this in conjunction with graph neural networks. These GNNs are designed to perform inference on data described by these graph structures. And this GNN can be directly applied to graph and provide easy way to do node, edge, or graph label in this prediction task. So this is the most popular GNN architectures nowadays. For example, the graph convolutional networks, or GCN. Here it uses the traditional convolutional layers, and also the graph attention networks, or GAN. Here use attention mechanisms in the nodes, and also the graph transformer networks that use the transformer architecture but implemented in graphs. And the next one, please. Well, another motivation of use these GNNs is that this is the 50 most appearing keywords for a sector research publication for the IC out there. This is the annual conference which focuses on cutting-edge AI research. And as we can see, these GNNs consistently rank in the top 10 keywords year by year. So they are popular mainly because they good performance in specific styles that we will see. So what about the usage of these text graphs? There are many research works that use this GNN to solve different NLP tasks. For example, sentiment analysis, authorship analysis, and general text classification tasks. In our case, we are more focusing in two specifically: authorship verification and generated text identification. The first one, let's say for one side, we have a set of documents for known author, and the other side we have a unknown document. So the idea here is to respond on this question. This document belongs to these authors, and the results, the output is yes or not. And the other one, more interesting, I think, nowadays, is, for example, generated text identification in the binary classification approach. Here you have one text, and the idea is to classify as a, or determine if the document were created by a machine or a human, right? And in the multi-class classification fashion, here you have the document as an input, and the idea is to obtain or classify as a some certain machine. In this case, it's maybe a LLM like ChatGPT, DaVinci, Cohere, and so on, or it was written by a human. So, having that, the idea is to test these approaches, our approach, the GNN with text graph, in different workshops or shared tasks. The idea is to compare this approach with other systems and the baselines. So we usually participate in the PANCLEF workshops. This is a network initiative for stereometric and digital text forensics. And also another is the IIMAS. This is a campaign for NLP in Spanish and other Iberian languages. So before talking about our results in this shared task, I'd like to share with you this architecture overview of our approach. The idea is having the text document as an input. The first step is apply the text to graph transformation using our library. Then an important step is to apply the node feature initialization process. Here we can use different methods like the traditional one, back of words, maybe some based on word embeddings, the word to back, document to back, and also obviously some LLMs. And having the text graph with the node feature initialization, we serve this as an input for a GNN using different kind of architecture that I showed, maybe the graph attention networks. And as an output, we will obtain the graph document embeddings that we can use for a, let's say, downstream task like a train a classification model to solve a specific task like the generated text identification. The next one, please. So this was the work to the PANCLEF 2023 for the authorship verification. Here we implemented a heterogeneous graph convolutional network for authorship verification. Here is the same architecture but with some variation. The idea here is taking the text to graph transformation. Here as a feature extraction, use a graph convolutional network. Then we apply some post-processing to this kind of problem, and lastly we classify a neural network, train a neural network. Here we obtain better performance compared to the baseline and achieve the fourth place on the leaderboard. If I remember well, it was about 30 or 40 systems, so it was good. The next, please. And related to the IIMAS 2024, this is the IIMAS textification for the automatic text, the generated text identification. Here we use the base GNN approach that I showed before, but here we integrated different multilingual LLMs and stylometric features to improve the performance of this system. Here we participated in two subtasks. The first one is the binary classification. That we obtain a F1 score of 71.8, and we rank the fourth place of 54. And for the subtask 2, we obtain, this is the multi-class classification approach, we obtain the 51% of F1 score and rank the second place out of 14. And the next one, please. Well, we are working some of our current and future work. We are trying to generate new graph representation and testing like the integrated syntactic graph. There are a lot of graph representation that we can try and test. So we are working on that also. Another interesting thing is to apply to other tasks that we think it could obtain interesting results, like the name entity recognition, style change detection, authorship profiling, and so on. And related to the library that we were working, the text graph API, we have a lot of things in mind, adding new feature functionalities to this graph, to these APIs, such as graph exploration, more parameterization, and so on. And obviously, and lastly, the try different GNN architectures to test different approaches. And I think it's all. Thank you.
Okay.
Any questions?
Very good. Some questions? I am interested in something, but if you have a question.
Do you think that the graph-based neural networks will always give better results than just neural networks without graphs? Why do you think so? Apart that you are doing this thing and you are very fond of it.
I'm going to try and explain that with this. The short answer, I think, is for the information that are extracted from the graph. The idea here, for example, is, and it works different from the traditional neural networks. For example, here you have the input graph and have some feature representation for each one. So the idea here is you have the target node and you build this computational graph. And the idea here is I'm going to pick this node A and I'm going to take the neighbors of the node A, in this case is B, C, D, and I'm going to obtain the features of these neighbors and update the feature of this node with information of the neighbors. So I'm going to obtain a, let's say, different representation, and based on the structure on the graph, and the idea is to will obtain a better learn feature, I think.
Well, as I understand, the idea of the graph is, okay, I will help the neural network. Poor network cannot work well. So I will help it, I will add some information, I will build the graph. This is the idea. But in practice, we also tried to help in some way to a neural network. But it turns out that neural network is so powerful that this extra information that we try to add can even make it worse. So, well, if you are using this, yeah, this is interesting. But it would be nice that, okay, you say, I use graph neural network and I get this result. And then you say, I use the same neural network without graph representation, and always compare, because in practice, sometimes it is even worse with graphs. Maybe. Helena will know what you I like graphs.
No, he has done that. He has done that experiment. And yeah. Here, no, yeah, this is better.
This is better.
Yeah.
Always. Sometimes.
Yeah. We are working on a paper for ACL actually now, and the results of these experiments will be in that paper.
Yeah.
Okay, mathematically, I have a question. Have you thought about this? These of course are binary graphs because you represent a relationship 1 to 1. It's like 2 nodes, 1 edge. Have you thought of different like NR graphs to moving up, like for example, relationship between 3 nodes, or other kinds of relationships? For example, binary relationships or tertiary relationships. Are these anything that you're interested in? Because I saw some research recently from Wolfram, Stephen Wolfram, and what's the name? Goddard. Forgot the name of the other guy. And they show that if you add more different, they call it a hypergraph, which you have binary and tertiary and quaternary different representations. They get better results for some specific applications. Have you thought about this?
We haven't tried that yet. It would be interesting. I think it would be improve that, having more relations than only one. But yeah, we could try that, but I think it could be computational expensive. Because doing this one only with one relation is computationally expensive now. So, but if we have the more power, I think the hardware, yeah, maybe we could try that. It could be interesting. But, yeah.
Okay, because there are certain libraries from Wolfram that do exactly this.
Okay.
Probably you could try that. Of course, it's Wolfram and you only have a very small free usage for that, but you could compare with what you have.
We can try that.
Yeah, I think it would be really interesting. And in any case, I'm not well versed into graph neural networks. What would be the main inner difference, like how they train or how they work, their inner workings between a regular neural network and deep neural network and graph neural network?
The main difference is this one. It's the way they extract the features based on the graph structure and extract or combine the features based on the neighbors of each of the nodes.
So let's say it's a regular neural network, which we're feeding what the graph edges as a vector, or it's a different architecture within the graph neural network.
You say if the edge vectors, if we
Yes, well, you're feeding graph information into a regular neural network, or it's a specific.
And it's a special kind of architecture. I think it's the basis is a neural network, but it is adapted that works differently. It is adapted to work with graphs. Yeah, this is slightly different with that.
Dumbing it down for me, can you use, like, for example, gas to build a graph neural network, or do you need specific libraries?
No, yeah, actually here I use the PyTorch library, but yeah, you can use Keras.
And your API, is it available online? Is there some
Yeah, it's public available in the Python repositories, so you can install it with pip install Textograph API and you can test it.
That's really nice.
Real projects.
Thank you for your next one. My question is maybe, do you think that your methodology is better because your methodology is ranked fourth in both shared tasks? So do you think your methodology is better? And what was the first, second, and third ranked methodologies if you are expert?
If I remember well, the first place it was about they use an ensemble of multiple LLMs. I do not remember how many, but yeah, that was the first place. They took a lot of LLMs, applied fine-tuning and assembled that, and yeah, that was yeah.
That's a lot of fun. Okay.
Can you use LLM with graph-based neural network? LLM, large language.
Using combination.
Just how do they relate?
The way we are combining this is in this part. For example, here we take apply a fine-tuning to the data and use this LLM to initialize the node feature for each of the nodes. And yeah, we achieve better results using this kind of LLMs, obviously, compared to other traditional ones, like word2vec and so on. And actually, we obtain better results for the LLM itself using this approach.
But you cannot just insert it into your pipeline. LLM.
No, only in this way. We as a separate part and initialize.
Thank you.
No, it's our turn. We have about 12 presentations.
Okay.
Oh, just. Ladies first.
No,
Te puedo echar.
Sí. Do you have a port for this? Ah, yes, for the camera. ¿Tienes otro de estos?
O una memoria USB. O alguien quisiera Mac que comprarse.
No, este no estaba completamente conectado. Ajá, le faltaba.
Hola, mi nombre es Cecilia González Garbín, soy estudiante de maestría y les voy a hablar un poco sobre mi tema de tesis, que es un traductor automático de la lengua purépecha al español con redes transformers. Siguiente. Bueno, pues en México existen 67 lenguas indígenas, cada una con una visión única del mundo. El purépecha es una de ellas. Es hablado aproximadamente por 128,000 personas, principalmente en el estado de Michoacán. Está amenazado por el predominio del español y la falta de tecnología que apoyen su uso. La ausencia de herramientas de traducción limita el uso y la preservación del purépecha. Un sistema de traducción entre purépecha y español no solo reduciría estas barreras, sino que también contribuiría a la inclusión digital de la lengua. Preservar el purépecha es clave para la identidad cultural de Michoacán. Siguiente. Bueno, pues básicamente el objetivo es crear un sistema de traducción automático preciso y accesible y explorar distintas arquitecturas como modelos con RRNs, redes recurrentes y redes LSTMs y por supuesto modelos con arquitectura Transformers para encontrar la que mejor se ajuste a este problema de bajos recursos. Para la obtención de los datos se obtuvieron a partir de la Biblia en ambos idiomas, se descargó el HTML y se aparearon por versículos, dando un total de 6,471 oraciones, pero se observó que algunos pares de oraciones se diferenciaban demasiado por qué tan largas eran en ambos idiomas, no sabemos por qué, pero se decidió filtrarlas y al final se quedó con 5,151 oraciones. Pues estas oraciones se tienen que tokenizar. Básicamente se tienen que, como lo explica la figurita, elegimos tokens y luego les asignamos un valor numérico. Ya existen funciones que lo hacen automáticamente. Para las RNNs y LSTM se utilizó el tokenizer de TensorFlow y para los modelos preentrenados se utilizó el tokenizador designado para cada modelo. También se aseguró que se igualaran las longitudes de secuencia usando path sequences y data colero for sec2sec para los modelos preentrenados. Se realizó fine tuning a MBART50, Mariana MT, M2M100 y se trabajó con RNNs y LSTMs. MBART50 fue entrenado en 50, es un modelo multilingüe entrenado en 50 lenguas. Mariana MT se entrena en pares de lenguas y M2M100 también es un multilingüe entrenado en 100 idiomas. Para los parámetros, para los modelos con RNNs y LSTMs, se utilizó el mismo batch size, el mismo learning rate, se le tuvo que aplicar dropout y regularización L2, se utilizó el optimizador Adam y se entrenó en 75 épocas. Para los modelos preentrenados se utilizó un batch size de 16, learning rate de 5 a la menos 5. Para Mariana MT se utilizó 15 épocas. A MBAR50 se le tuvo que aplicar dropout a las capas de atención, activación y clasificación. Este se entrenó en 10 épocas. Para M2M100 se entrenó en 10 épocas. Se dividieron los datos en datos para entrenar y datos para validar. Se entrenó con 4.127 datos y se evaluó con 1.032. Pues en el entrenamiento se graficaron las pérdidas de entrenamiento y de evaluación. La línea azul es la de entrenamiento y la naranja es la de evaluación. Como podemos ver, la pérdida de entrenamiento va disminuyendo y al principio la de evaluación también, pero llega un punto donde incrementa. Eso quiere decir que el modelo se sobreentrenó, a pesar de que aplicamos las técnicas para evitar el sobreentrenamiento. Para Mariana MT observamos, la verde es la de entrenamiento y la azul es la de evaluación. Observamos que ambas disminuyen y que la de entrenamiento disminuye más rápido. Además, la de evaluación va hacia un punto y se estabiliza. Esto quiere decir que llegó a su límite de aprendizaje. Algo parecido pasa para los modelos M2M100 y MBAR50. Bueno, para evaluar la calidad de las traducciones, comparamos la similitud entre nuestra traducción generada y nuestra traducción de referencia. Para este trabajo se utilizaron las métricas BLEU, que básicamente calcula la media geométrica y la multiplica por una ¿cómo se llama? Penalización de brevedad. También se utilizó ROW, que mide la precisión y el recall de los enegramas, y posteriormente se mide el F1 score. Se utilizó ROW 1, que usa unigramas, ROW 2, que usa bigramas, y ROW L para la subsecuencia mayor. La métrica, el desempeño con redes recurrentes, observamos que comienza en 0 y va aumentando gradualmente, pero es muy bajo, o sea, no llega ni a 1. Bueno, la métrica BLEU está de 0 a 100 y la ROW de 0 a 1, entonces no llega ni a 1, demasiado bajo. Y vemos picos, lo que nos indica que pues no está aprendiendo como debería. Algo parecido pasa con las LSTMs, y pues mejora un poco, pero también no llega ni a 1. Para los modelos entrenados para Mariana M3, vemos que incrementa gradualmente en las últimas épocas. El incremento pues disminuye, esto quiere decir que llega a su punto máximo de aprendizaje, y pues el BLEU mejora mucho. Algo igual pasa para los siguientes modelos. Aumenta y